we're being asked to find the limit in this case. And so you might be thinking immediately to use L'Hopital's rule. Well, remember, you got to check some things first. And hopefully you've actually worked this problem out already. If not, pause the video here, write down and work through the problem before you watch it from here. You're going to learn a lot more that way. So if I'm going to find this limit, I do want to check these other possibilities first. So I'm going to start by checking just direct substitution. That's the simplest way to find a limit if we can. And so I'm going to just take that 0 and plug it in for x. So that's going to give me 0 squared on the top, which is 0, and then 1 minus the cosine of 0 on the bottom. Cosine of 0 is 1. And so this equals 0 over 0. That's one of those indeterminate forms. So that tells us, yes, we will end up needing to actually use L'Hopital's rule, because you'll notice in this particular case, there's no factoring that can be done, there's no conjugate to get rid of a radical, and there's no multiple fractions to be able to combine. So down to L'Hopital's rule then, where step 1 is to find the derivative of the numerator and the denominator individually. Now remember, this is not finding the derivative of the fraction. That would require using quotient rule. That's just finding the derivative. This is a special rule where we're actually finding the derivatives separately. All right, so when I do that, the limit notation is still there. So it's going to be the limit as x approaches 0, because we haven't plugged in the 0 yet to figure out what it equals. That only goes away in the very last step. And so I take the derivative of the top, which is 2x, and then the derivative of the bottom, that's going to be the derivative of negative cosine. And the derivative of cosine is negative sine, so a negative sine is a positive sine. All right, now let's plug in, see what that gives us. So then if I plug in 0, then 2 times 0 on the top is 0, and sine of 0 on the bottom, also 0. And so that just equals another indeterminate form, which means we can't know what it equals. So what do? We keep going. If I can use L'Hopital's rule to figure out this limit, then I can also use L'Hopital's rule to figure out this limit. So we're going to repeat the process of finding the derivative on the top and the derivative on the bottom separately. And we keep doing that until we get down to something that does not give us 0 over 0. All right, so next step, keep writing the limit as x approaches 0. Oftentimes people want to skip over that. That's just being lazy. It's going to create some bad problems, bad habits. All right, derivative on the top is just 2. Derivative on the bottom is cosine of x. Now let's go ahead and plug in the 0 again. Notice if I plug 0 in on the top, nothing changes. It's still a 2. If I plug 0 in on the bottom, cosine of 0 is 1. And so this equals 2, which is then our final answer. This limit equals 2.